Very good morning to all. So in the last session we had discussed about what is clustering, what are the different types of data which can be taken up for the clustering methods, what are the different applications of clustering. In this class we are going to take up the types of cluster analysis methods. So as we all know, there are we had also discussed this in the brief. So now we will be taking up in the detail. So the different types of clustering analysis which are there, we will be discussing it now. This we also call it as taxonomy of the clustering methods. So there are the clustering analysis methods can be divided into hierarchical methods, partition methods, grid methods, and model based methods. So cluster analysis can be divided into four parts, four different types. So the first one is partition methods, or we call it as partitional clustering. And the second one is hierarchical. Hierarchical clustering. The third one is grid based clustering. The last one is model based clustering. Fourth one is model based clustering. So these are the four different types of clustering methods. So now going on to the next level, the partitional clustering methods is further divided, or the examples for partitioning methods are k-means partitioning methods, and then we have density based methods, we have expectation minimization methods. So here this partitional can be further classified or can be taken as k-means method. We have density based methods, and we have expectation minimization. Okay. So in the hierarchical clustering we have agglomerative, one more thing is divisive. Agglomerative or divisive. Sometimes this agglomerative testing is also called as Agnes. A-G-N-E-S. This agglomerative type of clustering we call it as Agnes, and divisive we call it as Diana. So divisive we call it as Diana. So these are the taxonomy, or this is the taxonomy of the cluster analysis. Like the cluster analysis can be divided into partitional methods, hierarchical methods, grid based methods, and model based methods. So what is this partitional based methods, or what is this partitional methods? Partitional methods is a single partition or single level partition of objects. Basically speaking of this partitional methods, so here partitional methods is single level partition. Initially any partition, if you are doing it in a single level, we call it as single level partitional methods. So it is one of the clustering methods or clustering analysis techniques wherein which we are going to partition the given data set into smaller chunks, okay, into smaller chunks, and then we are going to analyze the things. So here, suppose we have n different data in our hand and we are applying this partitional methods. What we need to specify or how this partitional methods work is, initially at the starting point we need to specify the number of clusters, okay, the number of clusters, the number of clusters need to be specified a priori. Okay, the number of clusters are to be specified at the starting point itself. At the starting point in the sense, before going on to the partitional methods or before going on to the cluster analysis methods, we need to specify the number of clusters we need to have, and care should be taken that each cluster should have at least one element in it. Okay, each cluster should have one element in it, which means we should not have any empty clusters when we have created this. We should take care that we have non-empty clusters, and the number of clusters based on the data we need to specify it beforehand going on to the clustering analysis. Okay, so objects may be relocated between the clusters and clusters are refined. So you can, once you have created the clusters, the object might be redefined or relocated onto the clusters, but it should not be but any cluster or any element wherever you are relocating, care should be taken that the cluster from which you are removing the elements should not be empty. If it is empty, then you are not allowed to do that. So this is your partitional based or partitional cluster analysis. So here we have K-means method or K-means algorithm, which is a popular clustering algorithm which we can use. We have density based methods or density based cluster analysis. So density based cluster analysis means I give you a cluster and every cluster will have a certain radius. Suppose if my cluster is in a spherical shape, this is my centroid of the cluster and this is the radius from the outer from the centroid of the cluster to the outer boundary of the cluster. So whenever I am using this density based method, care should be taken that there is a minimum number of points available from the centroid to the radius, or given the radius of the cluster, there should be minimum number of points in that particular radius. If you are not maintaining that minimum number of points, you cannot go for this density based cluster. Next is expectation minimization. The next type of clustering analysis method is hierarchical clustering. So in this hierarchical clustering, it is opposite of the partitional clustering. We don't know what is the number of clusters we need to create. We don't know what will be the outcome. So in partitional methods, we knew the input size, or we knew what input we are giving to the system and what output also we are expecting, we knew that. But in hierarchical clustering, we do not know what will be the predefined class, but we know what are the inputs. So that is the difference between hierarchical and the partitioning clustering. So here in this hierarchical clustering, we have two things. One is agglomerative and one is divisive clustering. So what is this? We'll be looking out in the coming sessions. So next we have grid based and model based. These things also will be taken care in the coming sessions. So here, this completely we call it as taxonomy of the cluster analysis methods. Either you can call it as types of cluster analysis, or we also call it as taxonomy of cluster analysis methods. Clear? So these are the 4 different types of clustering methods which we have. So now we go on in detail with the partitional methods and the K-means method. Okay, as we have said here, partitional method can take single level partition and this partition is computationally efficient. Okay, this tend to be computationally efficient and more easily adapted for very large data sets. Whenever we have large data sets, when compared to hierarchical clustering, this partitional type of clustering method is efficient computationally and it is also easy to use for larger data set. So in the last session we also discussed about the desired features of the cluster analysis, right? So in the desired features we said that the clustering analysis method which we choose must be scalable in nature, which means it should work fine with the smaller data sets also, and it should work efficiently with the larger data sets too. If any clustering method which you are choosing is working fine with both smaller data set and larger data set, such clustering analysis method we call it as scalable in nature. So here this partitional method of clustering shows that it is scalable in nature and it is computationally efficient and it is easy to use for the larger data set. When we compare this partitional method with the hierarchical methods, which we are going to see in the next sessions, so hierarchical method is computationally expensive. It is more expensive because we do not know which method in the hierarchical to use, and it might be from a larger data set or larger cluster to the smaller elements, or it might start from a smaller element to a larger and larger cluster. So we don't know how it works, and with the data set which method to apply, we will not be knowing it at an earlier stage itself. So it is quite more expensive when compared to the partitional methods. So here the k-means method which we are taking up, so we are using this k-means method at the initial stage for the first explanation. So k-means method is refined in nature. It is iterative refined method. We call this k-means as iterative refined method. The algorithm is iterative in nature. It goes on refining the values at the last until we do not get any change. Until there is no change in the values which we get, we are going to continue this algorithm. So this algorithm we call it as k-means algorithm. So here they converge at a local minimum rather than a global minimum. This k-means algorithm falls under a category called as greedy algorithms. Hope you might have heard of these greedy algorithms in your analysis and design of algorithms subject. So this falls under the category of greedy algorithm or hill climbing algorithms. So we have this technique called as hill climbing. So either there or greedy algorithms this will work for. So here the main aim why this partitional method is being used is we need to reduce the variance of elements in the clusters and we need to increase the variance of different clusters. Like if I say I have two clusters, I have cluster A and cluster B. So now when I say cluster, it means it has some elements in it, right? So we have some elements. So now this partitional method, this is for explanatory purpose itself. We are not going exactly into whatever cluster it is there. This diagram I have just put it for the explanation purpose and for your better understanding. So this partitional method, whenever we are using this in the cluster analysis methods, so the main aim of this partitional method is to, one is reduce variance between elements of same cluster, which means the variance between the elements in the same cluster. If I consider cluster A, the variance between the two elements in this cluster A has to be reduced. That means it has to be very near to each other. And the variance between two different clusters. Here when I was speaking, I took up the elements into picture. Now I am taking two different clusters into picture. So the variance between two different clusters must be higher in range or increase variance between two clusters. Please make a note of this. So when I make this, so I have larger variance between the clusters. Since the partitional methods do not normally explicitly control the intercluster variance, heuristics may be used for ensuring large intercluster variance. So we need to make use of heuristics for large intercluster variance. So here heuristics means choosing seed values, that is choosing the values which you want to work with. So if you are doing that, then you can successfully get these things done, get the aim be met. So if you are doing this, this partitional methods is complete. So now we are going to discuss this k-means algorithm. So the k-means algorithm is one of the partitional methods algorithm, as I said, which we will be using to classify the given data onto different clusters or onto the cluster of or to the nearest cluster here. Okay, the partitional methods, the k-means algorithm is used to partition the data into the nearest clusters. K-means algorithm. So please take a note of this. Please take a note of the steps in this k-means algorithm. So for this k-means algorithm, we are making use of distance methods. So in the last class also we mentioned this distance methods. We saw Manhattan distance, we saw Euclidean distance and all those things. So here for k-means we will be using the Euclidean distance method. Euclidean distance, which is given by distance between 2 points x and y, is given by x minus xi the whole square plus y minus yi the whole square under root. So this is the equation to find the Euclidean distance between between 2 points. So here the k-means algorithm, please take a note of this. So we have 7 steps for this k-means algorithm. The first step would be select the number of clusters. Select the number of clusters. The second one would be pick k seeds as centroids. Pick k seeds as centroids of k clusters. Next is compute the Euclidean distance of each object from the centroids. The fourth step is allocate each object to the cluster it is nearest to. It is nearest to. Next is Compute the centroids of the clusters. Compute centroids of clusters by computing the mean of the attribute values. Of the objects in the clusters. So the sixth point is check if stopping criterion is met. Check if stopping criterion is met. Here add on, if yes, proceed, else go to step 3. So the seventh one is decide on stopping or splitting clusters or combine two clusters. Combine two clusters. So these are the 7 steps which are involved in this k-means algorithm. So initially, since this is a partitional method, so we need to select the number of clusters in this. So what number of clusters has to be maintained, we need to select it. After that, we need to pick k seeds as centroids of k clusters. So we need to pick the seeds from where we have to start the computation, and then compute the Euclidean distance of each object from the centroids. The centroids which we have selected here is a point. So from this cluster centroid, we need to find the Euclidean distance of every single object in the given data set, and we need to keep a track of it. Next is allocate each object to the cluster it is nearest to. So once we get the values of this distance, we need to allocate the given data onto the nearest cluster it is belonging to. Compute centroids of the clusters by computing the mean of the attribute value. So once we have computed the cluster values, we are going to find the mean of the attribute values of this particular centroids. Check if stopping criterion is met. So here for k-means algorithm, the stopping criterion would be if there is no change in the values which we are getting. In the sense, in the second iteration, if I get one complete set of values and the data has been divided into cluster 1 and cluster 2 efficiently, in the third iteration, again if I am getting the same data have been classified as cluster 1 and cluster 2 and there is no change in the classification, then we say that we have met the stopping criterion. So when we have met this stopping criterion, then we are going to stop this algorithm. So if it is available or if the stopping criterion has been met, we are going to go for the step 7, or else we are going again for the computation of Euclidean distance. So decide on stopping or splitting clusters or combining two clusters. So this is the k-means algorithm. So we will look into a problem on this k-means algorithm so that you will understand these steps better. Okay, so I'll erase this first. So take down the data set. So the data set given is Okay, so this is the data set we have. So now the question would be in the form of, the question which you might get would be like this: for a k-means algorithm, consider the following data set consisting of the scores of time variables for each of the given of each of the 7 individuals. So this is the values or the score of the individual in 2 different subjects. So apply k-means algorithm to group this data set into 2 clusters. So we need to group the data set into 2 clusters. So here we have initial clusters which has been given. That is, pick the seeds. The initial clusters, they have been given to us. So the initial cluster which they have given here is C1, that is the cluster 1 is equal to 1.0 comma 1.0, and the second cluster is equal to 5.0 and 7.0. So these are the scores. These are the scores of individuals. 7 individuals we have taken here, 2 different subjects, and these are the clusters, the initial clusters. So these are the initial clusters from which you have to compute this, or you have to classify this scores. So now, what does the algorithm says? Initially, we need to have the number of clusters. So here the number of clusters which we are selecting is 2, which means the value of k which we are taking is 2. Okay. The first step of the algorithm is select the number of clusters you want to classify in. So here I am taking the number of clusters as 2. Next, pick seeds. Okay, pick k seeds as centroids. So here I have taken 2 different seeds. One is C1 and one is C2. C1 is 1.0 comma 1.0. C2 is 5.0 comma 7.0. So here 1.0 and 1.0 is the first entry here, and 5.0 comma 7.0 is the fourth entry. So these are the clusters, initial clusters which I am selecting. So the next thing what I have to do is I have to find the Euclidean distance, correct? The third step is compute the Euclidean distance from the given centroids to the objects, correct? So now what we are going to do, so the step 1 is over. This is step 1. This is step 2. Next, step 3 is compute the Euclidean distance. Euclidean distance is given by d of x comma y is equal to x minus xi the whole square minus y minus yi the whole square, correct? So now what we have said? We have said the values, the distance between the clusters and the values has to be taken. So here the cluster is C1 and C2. The values are the data which has been given there. So now we are going to subtract the values. Okay, we will get it as subject and we have C1 distance and C2 distance. Subjects 1, 2, 3, 4, 5, 6, 7. Okay, here we are computing the C1 distance. For this we are considering both here. These two are xi and yi. This is x and y. For cluster 1, when I am considering the distance of cluster 1, C1 distance, I need to consider every single value with this C1 value, that is 1.0 minus 1.0 plus 1.0 minus 1.0 whole square under the root. So this will show it for 2 entries. So for the first one we are going to take it as root of 1.0 minus 1.0 whole square plus 1.0 whole square under the root. So here this is x, the value of this is x, the value here this is xi, this value is y, this value is yi. So 1.0 x minus xi, 1.0 minus 1.0 whole square plus 1.0 minus 1.0 whole square. So what will be the answer for this? The answer would be 0. Okay. For first subject, the C1 distance here would be 0. Understanding? So now the same thing for the cluster 1, distance of cluster 1 for the second one. It is 1.0 minus 1.5 whole square plus 1.0 minus 2.0 whole square. Under the root. So what will be the value for this? The value for this would be 1.18. Okay, the value for this would be 1.18. In the similar way, we are going to solve the values. So this will be 1.18, 3.60, 7.21, 4.71, 5.31, 4.30. So in the same way, for cluster 2, we are going to take these two values with these two values, which becomes, this becomes x for the cluster 2 distance, this becomes the xi, this becomes y, this becomes the yi. So it will be 5.0 minus 1.0 whole square plus 7.0 minus 1.0 the whole square. If you compute it, you will be getting the values as 7.21, 6.10, 3.65, you are going to get 0, 2.5, 2.06, 2.91. Approximate values we are going to get. Now, the next step after computing the Euclidean distance is we are going to have, or we are going to classify the values onto its nearest cluster. Here nearest cluster we are going to take the distances. This is the distance which we have calculated. Of this distance, whichever cluster is nearer or whichever cluster is smaller or whichever cluster is having the smaller value, such clusters we are going to assign with the values. So here, which is the value which is smaller in these two, in C1 distance and C2 distance, which is the smaller? It is 0. In 1.18 and 6.10, 1.18 is the smaller. In 3.60 and 3.60, we consider 3.60 is there, so it is the smaller. So these three things are smaller here. If you consider here, 7.21 is greater than 0, 4.71 is greater than 2.5, 5.31 is greater than 2.0, 4.3 is greater than 2.91. So we cannot take these. So here these three entries fall under the category of C1 cluster. That is, the subjects 1, 2 and 3 fall under, or these belong to cluster 1. Next, if I consider, as I said, 7.21 is greater than 0. Here the minimum value is 0. 4.71 is greater than 2.5. This is the minimum value. So here, if you consider, this will be the minimum and this will be the minimum. So this categorization we are going to do it. Fine. So now the values 4, 5, 6, 7 falls under the cluster C2. Four, 5, 6, 7 falls under the cluster C2. Any doubts? Okay, it falls under the C2 value. Now the new clusters are C1 which belongs to 1 2 3, sorry 1 2 3 which belongs to C1, and C2 we have 4 5 6 and 7. After this, what is the fourth step? It is allocate each step. Yes, the fifth step says compute the centroids of the clusters by computing the means. We are going to find out the average of the values here. So how we are going to find out the average of the values? See, cluster C1 we have 1 2 and 3. So 1 2 and 3 we have the clusters. So we are going to take up these three values, and we are going to compute the average. So how that is being done? See, 1.0 plus 1.5 plus 3.0 whole divided by 3, and 1.0, 2.0, 4.0 whole divided by 3. So that is how we are going to calculate the average. So for C1, comma 1.0, 2.0, 4.0. So this would be my average value. So for C1, what will be the average value? So for C1, what will be the average value? So it's 4.5, 5.5 by 3, it is 1.8. So this is 6 plus 7, 7 by 3 is 2.3, correct? So now the value of C1 would be 1.8 and 2.3. So in the same way, I will be calculating for C2. So C2 we are having the values of 4, 5, 6 and 7. The elements 4, 5, 6 and 7. So again we are going to do the average in the same way. 5 plus 3.5 plus 4.5 plus 3.5 whole divided by 4, because we have 4 entries. 7, 5, 5, 4.5 whole divided by 4. So it will be 5 plus 3.5 plus 4.5 plus 3.5 whole divided by 4, comma 7 plus 5 plus 5 plus 4.5 whole divided by 4. So now this will be my cluster 2. So the value for this would be 4.51. C2 would be 4.1 comma 5.3. Okay, so got this. Now this is the first iteration for this. So I said k-means is an iterative refined method. So here we are going to perform the second iteration by considering these two as the new clusters. Initial clusters we had considered 1.0 and 1.0, 5.0 and 7.0. Now after computing all these steps, we have got the new criterion or the new initial clusters. C1 is equal to 1.8, 2.3, C2 is equal to 4.1 and 5.3. So now we are going to change this. Okay. So this was the iteration 1. So now we are going to have the iteration 2 again. Okay. So here please remember, in the iteration 1 we had 1, 2, 3 falling in C1, 4, 5, 6, 7 falling in C2. Now again we are going to calculate the Euclidean distance as we have did in the last iteration. So this for the second iteration, when I compute, I will be getting the values as 1.5, 0.4, 2.06, 5.66, 3.19, 3.81, 2.7. For C2, we are going to get 5.3, 4.2, 1.7, 1.9, 0.6, 0.5 and 1.0. So now we have got these two distances. Again, what we are going to do is we are going to compare the two distances here, C1 and C2 of 1.5 and 5.3. 1.5 is minimum. We have to select minimum values so as to make it as a center. So 0.4 and 4.2, 0.4 is the minimum, 2.06 and 1.7, 1.7 is the minimum, 5.6 and 1.9, this is the minimum, 3.19 and 0.6, 0.6, 3.81 and 0.5, it is 0.5, 2.7 and 1.0, it is 1.0. So now, here you can see, in the first iteration, we had got cluster 1, the first 3 elements had fallen under the category of cluster 1. So here, in the second iteration, if you see, it has changed. Only 2 elements have fallen into the cluster 1 and rest all have fallen under the category of cluster 2. So here, this 2 falls in cluster 1, these 5 elements falls under the category of cluster 2. So second iteration, we got C1 is equal to, or C1 1, 2 belongs to C1, 3, 4, 5, 6, 7 belongs to C2. Okay, this plays a major role for the stopping criterion, because if there is no change in this classification, then we are going to stop the algorithm. Now here you can see the changes. The 3 which was there classified as a cluster 1 in the first iteration has now been classified into the cluster of 2. So now we need to check for the another iteration for the same. So how we are going to find the new clusters? The new cluster is found by taking the average of the clusters. So here 1, 2, that is 1.0 plus 1.5 by 2 plus 1.0 plus 2.0 by 2. Compute it. Compute that. So if I do this, I'll be getting for C1 the value as 1.25, 1.5. So for C2 we have 5 different values. So it is 3 plus 5 plus 5, 3.5 plus 4.5 plus 3.5. Whole divided by 5, since we have 5 elements, and then we have 4 plus 7 plus 5 plus 5 plus 4.5 whole divided by 5. So for C2 I am going to get the values as 3.7, 5.1. Okay, I am going to get the values 3.7 and 5.1. Now for the next iteration, my new clusters I have found out. It is 1.25, 1.5 and 3.7, 5.1. Using this, again I am going to repeat the k-means algorithm. 1.5 and 3.75 comma 3.75 comma 5.1. Okay. Now we have got the new initial clusters, we have got the values. Again I am going to compute the Euclidean distance for this. So this is the third iteration. So for the third iteration, x will be, x for C1 distance is 1.25, xi would be this, y would be 1.5, yi would be the b value. 3.75 is the x value for cluster 2 distance, xi is this, 5.1 is the y value for cluster 2 distance, 1.0 is the value for this. So now C1 distance here, if I am I will be getting 0.5, 0.5, 3.05, 6.65, 4.16, 4.77, 3.75. So this would be 4.9, 3.8, 1.3, 2.3, 0.2, 0.8 and 0.6. Okay. So so now again we have computed the Euclidean distance using these two initial clusters. Now the value of C1 and C2 we are going to compare again. So of 0.5 and 4.9, 0.5 is smaller, here again 0.5 is smaller, here 1.3 is smaller, here 2.3, 0.2, 0.8 and 0.6. So now if you see, elements 1 and 2 falls under the category of cluster 1, 3, 4, 5, 6, 7 falls under the category of cluster 2. Okay, falls under the category of cluster 2. The minimum values we have taken here. So for the third iteration, so 1, 2 belongs to C1, 3, 4, 5, 6, 7 belongs to C2. So this is for third iteration. Fine. Now compare the second iteration and the third iteration. Is there any changes? No, there is no changes. In the second iteration also we got elements 1 and 2 fell in the category of cluster 1, 3, 4, 5, 6, 7 fell into cluster 2. In the third iteration also we have got the same values. 1 and 2 falls under cluster C1, 3, 4, 5, 6, 7 falls under cluster C2. So now the sixth step of the K-means algorithm. Check whether the stopping criterion is met. The stopping criterion here is unchanged values in the clusters. So we are seeing unchanged values. So we say that the stopping criterion has been met, and hence at the last stage the category the elements 1 and 2 falls under the category of cluster 1. The elements 3, 4, 5, 6 and 7 falls under the category of cluster 2. Fine. So that is our final concluding statement. So this is how K-means works. So let me brush up K-means, brush up what we have studied in this class. So in this class we studied about the types of cluster analysis methods. We studied about the partitional methods. We studied about the hierarchical methods, the grid based method and the model based methods. So the cluster analysis method can be divided into 4 different types. One is partitional method, hierarchical method, grid based methods and model based methods. In the partitional methods we have K-means, density based and expectation minimization. In the hierarchical methods we have divisive method and agglomerative methods. So partitional method is a cluster analysis method in which we follow few properties, like the number of clusters has to be told or has to be specified before the procedure. So the first step of the partitional method is we need to specify the number of clusters. Next is it is a single level partition. So the partitional method is a single level partition. So we know what the input is, what the output should be. Both we know. This falls under the category of supervised learning. Next is the partitional method is efficient for computation, or if it is computationally efficient, and it is very less expensive to use when compared to hierarchical clustering methods. Fine. So now in this we studied about the k-means algorithm. So k-means algorithm has 7 different steps, of which the first step is select k clusters, or the select the k number of clusters. The second step is, what is the second step? First is select k number of clusters. Second is pick k number of seeds, k seeds, the clusters. And the third step is compute the Euclidean distance. Fourth one is check out for the allocate the objects into the nearest cluster by checking the lesser distances. The fourth one is compute the mean of the attribute values. The fifth step is find out the new clusters. The sixth step is check whether the stopping criterion has been met. If the stopping criterion has been met, then proceed for the next step. If you have not met with the stopping criterion, go to step 3, which is the computation of Euclidean distance. Okay. In the seventh step, which is optional in nature. Either you can go for splitting of the clusters or merging of the clusters. So here we saw one problem wherein which we had 7 different subjects. The scores of 2 different individuals for 7 different subjects was given. So we had also been given with the 2 initial clusters to consider on, 2 different clusters to consider on, and then we had the number of clusters as 2. So based on these things, we computed the Euclidean distance, and from the Euclidean distance we checked into which category or which cluster does the element belong to. We did this until we got no change in the final results. Okay, we got no change in the final results. As you can see here, the second iteration we got the value as elements 1 and 2 falls under the first cluster, 3, 4, 5, 6, 7 falls under the second cluster. In the same way, for the third iteration also we got the same values. Here we say that the stopping criterion has been met, and when we say that the stopping criterion has been met, we say the k-means algorithm has completely done and we can terminate the algorithm here. Okay. So in the next class we will be dealing with the hierarchical methods, agglomerative and divisive methods, and we will be taking up the next concepts. Thank you so much.